Good day, my name is Cheng, matrix number MG11018. Today I would like to explain about the second law of thermodynamics. Second law of thermodynamics not limit to identify the direction of process. It also adjusts the energy, has quality and also the quantity. The second law of thermodynamics determines the theoretical limits for the performance of commonly used engineering systems such as the heat engines and refrigerator, as well as the predicting the degree of completion of chemical reaction. The process occurs in a certain direction, not in any direction. For example, transferring heat to a wire will not generate electricity. Okay, thermal reservoir. Thermal reservoir is a large body that can absorb or supply heat without undergoing any change in temperature. A body do not actually have a very large to be considered as reservoir. Small also can be considered as a reservoir. Any physical body whose thermal energy capacity has large relative to the amount of energy the supply and absorb can be grouped as one. A reservoir supply energy in the form of heat called source, and while another is a reservoir absorb energy in the form of heat called sink. Okay, supply heat is called source, while another absorb heat is called sink. Okay, next is the heat engine. Heat engine is a device that needs to produce work. The work can be converted to heat directly and completely, but converting heat to work requires the use of some special device, which is the heat engine. Therefore, heat engine is very useful device. The characteristic of heat engines have four. First is receive heat from high temperature source, which is solar energy. Second is convert part of this heat to work in the form of rotating shaft. The heat is produced to work. Third is the reject the remaining waste heat to a lower temperature sink, which is our atmospheric. Last is the operating on a cycle. Okay, next is the net work output of the power plant. Okay, the net work output is equal to work output minus work input. As we know, no mass enter or leave in the system is called closed system. For a closed system, the internal energy is 0. Del U is equal to 0. There is no heat transfer in a closed system. So we also can be derived as the net work output is equal to heat input minus heat output. Next is thermal efficiency. The symbol is like this. This is a symbol of thermal efficiency. The fraction of the heat input that is converted to a net work output is measured for the performance of a heat engine. Okay, high temperature reservoir at high temperature release high energy to the heat engine, and it also will release net work output, and also after that we'll release a lower heat to the lower temperature reservoir at low temperature. We also can re-express the formula, which is the thermal efficiency is equal to net work output divided by total heat output, total heat input. We also can re-express as 1 minus Q output divided by Q input. Since the W net out is equal to Q in minus Q out. For information, QH and QL is a magnitude, a positive quantities, and the direction is easily to determine. Okay, next is another second law of thermodynamics, the Kelvin-Planck statement. Kelvin-Planck statement is impossible for any device that operates on a cycle to receive heat from single reservoir and produce a net amount of work. It can also be expressed as no heat engine can have a thermal efficiency of 100% for a power plant to operate. The working fluid must exchange heat with environment. Okay, next subtopic is refrigerator and heat pump. Refrigerator and heat pump is the transfer of heat from low temperature medium to higher temperature medium, which is require specific device called refrigerator. In the refrigerator that have 4 components, which is the boiler, compressor, evaporator, and also the expansion valve. This is the diagram of the refrigerator. This is the boiler, compressor, evaporator, and also the expansion valve. Okay. The refrigerator enter the compressor as the vapor, and then is compressed to the condensed temperature. Here is condenser. And then leave the compressor at higher temperature. This is leave as a higher temperature and cool down and flow through the condenser by injecting heat to surrounding through the expansion valve. After that, enter the evaporator, heat from the refrigerator space, and the cycle is complete. This cycle have to pass through compressor, boiler, expansion valve, and also the evaporator. This cycle is completed. Okay, the coefficient of performance, COP. We can derive as COPR is equal to desired output QL over required input W net in. We also can be expressed as 1 over Q H over QL minus 1. Since W net in is equal to QH minus QL. heat pump. Heat pump also can be write as HP. Heat pump is a device that transfers heat from low temperature to higher temperature. COP, heat pump, is equal to desired output QH, which is desired output, W net in, which is the required input, and also can be expressed as 1 over 1 minus QH over QL, where the COPR is equal to 1 over QL over QH minus 1. This is the equation of the heat pump. Okay. Next is the Clausius statement. Clausius statement states that it is impossible to construct a device that operates in a cycle and produce no effect other than the transfer of heat from a low temperature body to a higher temperature body. The equivalence of two statements, which is the Kelvin-Planck and Clausius statement, are equivalent in their consequences. Kelvin-Planck, as before I already explained, now I explain about a combination of two statements, which is the Kelvin-Planck and Clausius statement. Higher temperature resolver will release high energy to the heat engine and also will release W net to a refrigerator. The refrigerator will release QH and also QL. This QL is come from the low temperature resolver. At low temperature, this one is from the higher temperature. Okay. The QL is come from the lower temperature resolver at low temperature. Okay. The thermal efficiency convert all heat QH received to work. The work supplied to the refrigerator that remove the heat in the amount of QL from low temperature resolver. And it also reject the heat in the amount of QL and also the QH and QL. Thus, the combination. This is the combination of two devices, which is the Kelvin-Planck and also the Clausius statement. Okay. Now I would like to explain another, which is the proportional motion machine. The proportional motion machine have two kinds, which is the first law is the first law of thermodynamics and also the second law of thermodynamics. First law of thermodynamics is called the machine is called proportional motion of first kind, while the second law of thermodynamics is the proportional motion of second kind. The proportional motion machine is a device that violates either law is called a proportional motion machine. Okay, now I'm going to draw out the proportional motion machine. It has few components, which is the boiler, the boiler is connected to a generator. The the generator will release out the network output, and the generator is connected to a turbine. Or the turbine is connected to a condenser. Turbine also connect to a pump. The pump is connected to a condenser, turbine, and also the boiler. This is the system boundary. Okay. The steam placed inside the boiler. The steam inside the boiler. And the part of the electricity generated by the plant is used to power the resistor as well as the pump. The rest of electricity supplied to the electric network as network output. Okay, now I would like to explain about the reversible and irreversible process. Okay, now is the reversible and irreversible process. The definition of reversible process is a process that can be resolved without leaving any trace on the surrounding. While the meaning of irreversible process is all real processes are irreversible. It occurs due to the friction, heat transfer, under strain expansion of gas. Next is the internal reversible. It's also a non-irreversibility occur within the boundary of the system during the process. Next is the external reversible. No irreversibility occur outside the boundary of the system during the process. While the total reversible is the combination of internal and external, or it calls simple reversible. That is no irreversibility within the system or its surrounding, where is the internal and external is equal. Okay. Next, I want to explain about the Carnot cycle. The Carnot cycle that working on reversible process. It serves as a starting point to deliver actual cycle. The Carnot cycle also can be divided into two cycles, which is clockwise cycle and anti-clockwise cycle. Clockwise cycle for heat engine, while the anti-clockwise cycle for refrigerator. This one is the clockwise cycle, is for heat engine, while the anti-clockwise cycle is for the refrigerator. Okay, now I would like to explain, and the Carnot principle is the efficiency of an irreversible heat engine is always less than the efficiency of a reversible. Means the irreversible heat engine is less than the reversible heat engine. The efficiency of all reversible heat engine operating between the same two reservoirs are the same. The two reservoirs are the same for the reversible and the irreversible. Carnot device also can be differentiated into three, which is the Carnot cycle can be divided into three. First is the Carnot cycle device. Heat engine, Carnot refrigerator, and also the Carnot heat pump. This is the three device for the Carnot cycle. First is Carnot heat engine, second is Carnot refrigerator, and also the Carnot heat pump. Okay, now let's explain about the thermodynamic temperature scale. The thermodynamic temperature scale is a temperature scale that is independent of the properties of the substance that are used to measure temperature. Okay, this is the formula. Now we write out the thermal efficiency formula is equal to is equal to G T H T L or QH over QL is equal to F T H T L. Okay, the thermal, draw the diagram of the thermal temperature scale. Thermal energy reservoir at T1, and then release Q1 to heat engine A. Heat engine A also release the work A. After that, the heat Q2 release heat to heat engine B in a certain temperature. When it reach a certain temperature, the Q1 only will release heat to the heat engine B. Here also release Q3 to the thermal energy reservoir at T3. Besides that, the thermal energy reservoir at T1 also will release heat to heat engine C. And it also will release work C. After that, it will release Q3 to the thermal energy reservoir at T3. They have three engines separately, which is the heat engine A, heat engine B, and also heat engine C. Both three engines also will release work. Okay, now I'd like to express out the formula for the thermodynamic temperature scale. Q1 over Q2 is equal to F T1 T2, while the Q2 over Q3 is equal to F T2 T3, and also the Q1 over Q3 is equal to F T1 T3, and these three also can be expressed as Q1 over Q3 is equal to Q1 over Q1 Q3 Q3 Q2 over Q3. This one is Q2. Okay, these three can be write as Q1 over Q3 equal to Q1 over Q2 multiplied by Q2 over Q3. This is a combination of these three. Become one formula. After that, F T1 T1, T3 is equal to F T1, T3 multiplied by F T2, T3, T1, T3. Okay, and F T1, T2 as well as sigma T1 over sigma T2, and also the F T2 T3 is equal to sigma T2 over sigma T3. Okay, after that, it also can be expressed as QH over QL is equal to sigma TH over sigma TL. Okay. We also can write as QH over QL over is equal to TH over TL. This is the thermodynamics Q formula. Okay, now let's explain about the Carnot heat engine. The hypothetic and heat engine that operate on the reversible Carnot cycle is a Carnot heat engine. The formula can be write as the thermal efficiency is equal to 1 minus HQL over QH. This formula has been explained before, and also can be write as 1 minus TL over TH. This is the formula for the Carnot heat engine. Okay, after that is the Carnot refrigerator and heat pump. The Carnot refrigerator can be write as COPR equal to 1 over QH over QL minus 1. For the Carnot relation for the reversible refrigerator is COPR relative is equal to 1 over TH over TL minus 1. For the Carnot heat pump, this is the Carnot refrigerator. This one is the Carnot heat pump. The formula is HP means the heat pump is equal to 1 over 1 minus QL over QH. For the Carnot relation for reversible heat pump is COP HP relative reversible is equal to 1 over 1 minus TL over TH. This is all about the second thermodynamics law. Okay. Now I'd like to explain again about the second law of thermodynamics. Second law of thermodynamics not limit to identify the direction of process, and it also exerts that energy has quality as well as quantity. The second law of thermodynamics also determines the theoretical limit for the performance of commonly used engineering systems such as heat engine and refrigerator, as well as the predicting the degree of completion of chemical reaction. That's all for the second law of thermodynamics and my presentation. Thank you.